So imagine there is a question again. So there is a table and a chain is kept on the table. Who is having a mass m and length L. So similar to like thing. So it has a friction mu. So friction coefficient is there mu. Do you understand everybody? All of you? Mu it is there. So find, all of you observe, find maximum length. Find maximum length of chain that can hang. That can hang means we have to find this is the height, this length. Am I right, guys? All of you? Hang off table without slipping. What is that, everybody? Without slipping. So we can balance the chain. Am I right or wrong? You all people also can normally perform it, right? So we can keep a chain on a table so that it is some part is hanging, some part is horizontal on a baseline, such that the chain should not slide or should not slip off. Clear, everybody? So that is the length we have to find it. Am I right, guys? Everybody clear, understanding what I'm saying? All of you? Yes, sir. So total length is L. So we have to find this is how much length so that the chain should not fall down. That is what is our target. So option A, L into mu divided by mu square plus 1. Option B, mu L divided by mu plus 2. Option C, L divided by 1 plus u, mu. And next one is mu L divided by 1 plus mu. Shall we start? I will teach you, you observe. And then we'll proceed. Is it okay, guys? Yes?
Yes, sir.
Yeah. So all of you observe very carefully. So we all knows that total length of the chain. What is the total length of the chain, everyone? What is the total length of the chain I have taken? Please respond. All of you. What is the total length? Total mass is m and total length is what?
L, sir.
Let me consider, let me consider this length is x. This length is how much? Everybody should speak. What is this length? X. So if this length is x means, then what is this remaining length? Anybody can tell? Remaining length?
L minus X.
L minus x.
L minus X.
Yes. So please try to speak if you speak only. And as it is a friction is existed. So what is the friction formula? Mu into, what is the friction?
N.
Mu into n.
Limiting.
Mu is mu. N is equals to what? We all knows that. N is equals to what? Mg. Am I right, guys? Mg.
Yes, sir.
So mu is equals to mg. But what mg? Total mass or only the mass which is hanging up? Anybody? Yes, please. The mass which is hanging only. Am I right or wrong? Total length having a total mass m. Then length will become x means. Already we have done it. I told you, unitary method. Then what is the mass of this particular length? Total mass divided by total length into length of that particular one. That is the length of this particular, mass of this x. Same way, mass of this L minus x, anybody can tell me? Total length is equals to total mass. Now length is equals to L minus x. Then mass will become what? Total mass divided by total length into what? Length.
L minus.
That is what. Are you understand, all of you? Clear? Yes, please.
Sir.
Now, if you observe very carefully, Pradosh, it should not slip off. It should not slip off. Means in the sense of which is greater? Frictional force is greater or gravitational hanging force is greater? Anybody? Yes,
Sir.
please. Frictional force is greater. Am I right or wrong?
Frictional force.
Yeah. The force which is acting downward, potential energy. So what is the potential energy? Tell me. Potential energy equals to how much it is? What is the mass? That is what mass is equals how much, Ra? That is what the mass which is acting downward direction. So frictional force must be greater than the mass which is acting downwards. What is the mass which is acting downward? Mass of
ML.
M
by
L into X.
okay, that is what it is. Okay, and or else we can say the mass of this particular one, must be greater than this. Am I right or wrong, everyone? Yes, please respond, all of you. Yeah, so mass of this one is must be equal greater than, okay, greater than is equals to downward part, then also body won't be sliding. Or if you notice it, this both are equal also, it will never slide off. Am I right or wrong, guys? It will reach us to the maximum limiting friction, but they won't be slide off. Am I right or wrong? Everybody? Yes, please.
sir.
So this is only frictional force. How to find it? This is not the mass of this one. This is just a mass of that one. So that is only frictional force, because frictional force always act opposite direction. Am I right or wrong? Everybody?
Yes.
So
Yes,
how to
sir.
find frictional force? Check it, everybody. Mu into, what is the mass of that one? Check it, everyone. How much is the mass? Mass of the horizontal one. How much?
ML divided
M
divided by L into L minus
L
X.
into so M L divided by into L minus X into G. Am I right, Pradosh? That is only is equals to frictional force. Clear, everybody? Yes. So frictional force is greater than this mass. Definitely the body won't be slide off. That is only. Or else even both are equals to also they won't fall off. That's all it is. So the frictional force which is exerting on the chain, more than the mass of this one, so that the body won't be fly off. Am I right or wrong, everybody? Yes, please. All of you. So that's all. So the frictional force is equals to mu ml into L minus X into G. So both are equal, the body won't be fall. So mu L into L minus X into G, which is equals to m by L X minus X into G. So both the cases, will get cancelled. Next one, LL also can get cancelled. Am I right or wrong? All of you? Then GG will get cancelled. So what is remaining? Verify it. Mu into L minus X, which is equals to X. Is it okay, everybody? So next, mu L minus mu X is equals to X. Clear? Now, mu L is equals to mu X plus X. So X is common. So if I take X is common, what will happen? X, everybody, mu plus 1. So mu plus 1 will come this side. So mu L by mu plus 1. So what is the option? X is equals to, check it, everybody. Mu L by mu plus 1. So what is the, which option is correct? X is equals to. All of you verify. What is the given options are right? Option D. So we have to keep a X length in such a way that mu L by L 1 plus mu, so that the body won't be slide off. Is it okay, guys? Everybody clear? Understand, Amma?
Yes, sir.
So please make it. Understand and solve. I hope you all understand. Everybody clear? All of you?
Yes, sir.
So the same question will continue for next two. That's why. If you are able to solve this one, I'm happy. Do you understand, guys? This one? Everybody, girls, boys, Mr. Murali, Rishi. Okay? All of you? Now, the same question, let me continue. Continuation, guys. There is another subdivision. So again, the same question. So we have found that this should not be slip off. So should not be slip off means what is the length of the X? Everybody. What is the length of this X? We have found it already. So X is equals to what? Mu L divided by, respond, mu L divided by 1 plus mu. Am I right or wrong? Please respond. So now what is this length? Can you tell me? We have done the formula. What is this length? I want to know. What is this length I have written? Check it. L minus X. Correct or not? So L minus X means L minus X. So L minus X means what? Mu L divided by 1 plus mu. So let me take now. Both cases L is common. So L is common out. If I take it 1 minus mu divided by 1 plus mu. Will you all agree with me? Please respond, Ra. So we'll take 1 plus mu is LCM. So 1 plus mu minus mu. So minus and plus will get cancelled. So which is equals to L into 1 by 1 plus mu. So that what is the length of this chain, everybody? What is the length of this part? It is not slipping off. So this length is what? L into 1 by 1 plus mu. And what is the length of this part which is hanging? What is the length of this part? All of you. Mu L divided by 1 plus mu. Is it okay, everybody? Pradosh? Understand, Ra? So find the length of the chain on the table. Table means how to find it. Understand the question now? What is the question? Find the length of the what? Chain. Okay. Chain on table when it is just about to slip. About to slip. About to slip means by the time also limiting friction. Am I right or wrong?
Yes, sir.
Sir, no. Everybody, please respond, Ra.
Sir.
Yes. So the length of this chain x is mu L by 1 plus mu. Length of the chain which is present on the table when it is ready to slip is L into 1 by 1 plus mu. Do you all understanding, everybody? Any doubt? Please respond. Clear? The same question. If the same question all of you remember. So what is the length of the chain? It is ready to slip or it's not slipping. What is the length of the chain on the table? Everybody? L into, please respond. 1 by 1 plus mu. So can I write this one as a L by 1 plus mu? Will you all agree with me? Yes. And the chain of the length, which is chain of the length, which is acting downwards. This is L minus X. And this is X is equals to, what is the formula? Mu L divided by 1 plus mu. Okay, guys? All of you? Now the question is, find the total work done. Find the total work done by friction. Total work done by friction when chain slips off completely from the position. Slips off completely from the position. Is it okay, everybody? Slips off completely from where? Everybody, from the, please respond, position. So we all knows that work done is equals to what? Work done is equals to what, guys? They are asking work done now. Work done formula, force into displacement. Am I right or wrong? So force means here frictional force only. So friction means what is that? Frictional force they are asking. Anybody? Frictional force means what, Ra? Mu into N into S. Am I right or wrong? Mu into N means what? Mg. Mg into S. Yes or no? All of you? Yes.
Yes, sir.
Yeah. Now, if you observe very carefully, here is only very important thing. So, for finding M, if you all observe very carefully, so we all knows that if you take any particular point, this part, this part, and this part, and this point, what they're saying, find the total work done by the friction when the chain slips off completely from the position. Completely from the position means this point is completely coming here and it is falling down. That is what the meaning they are saying. Will you all agree with me? All of you? Yes, please.
Yes, sir.
Now you tell me, if the chain is traveling like this one, is it every point is, for example, I'll take this small mass, dm. If I take this small mass, dm. If I take this small mass, dm. Is it everything is traveling the same distance? Is it true? No. Am I
No,
right or
sir.
wrong? So the frictional force on this point is different and this point is different and this point is different. It is not constant. It is varying. So if I take total length is m, then particular part I am taking, the distance of the particular part, the mass of this one is dm and the particular path which is traveling is, can I take it as a dx? Everybody, will you all agree with me? Yes, please, because different one is traveling different length. Am I right, Rudreswa? Clear? So frictional force is not same at every, frictional force is not same at every point. So I'll take total length is m means, sorry, length, total length of the chain is m means, then particularly length of particular part, that small part is dx I have taken. So dx is equals to what will come? You should speak total mass divided by total length into length of that particular. Yes or no? That is what. So we all know that frictional force is equals to mu into mg. So mu into m means what? A mass of this dx. That is what? M divided by
M
L.
by L into dx.
Yes, dx into g. So that is what? F. Clear, everyone? So that F is equals to only work done. Am I right or wrong? Amount of friction is equals to only work done. So I will replace. So work done by that particular part. Total work done means capital W. So small amount, because it is a dx only, small region. so that work done is also become small part, dW. So dW is equals to F into X. We all knows that work done is equals to force into displacement. That's all. So if I take it, so work done integration, if I apply, so what is the force equals to? We got it. What is the answer? Check it. What is the force? Mu M divided by L, understanding, into dx into g into x. Is it right or wrong? Everybody? Yes, please. All of you.
Sir.
And limits, can you tell me? From 0 to where? Check it, all of you, limits. The total length is, it is starting. This point is sliding, next point is sliding, next point is sliding, next point is sliding, next point is sliding, and last point is sliding. So what is the total length? Limit. From 0 to, what is the total length of this one? Yes, please. L by
L by 1
L by 1 plus u. That is the limit. So L by 1 plus u
by 1 plus nu.
limit. Okay. So now you can apply. We all knows that mu is the constant, m is the constant, g is the constant, L is the constant. So integration of what will happen? X dx. So limits is 0 to L divided by 1 plus mu. Is it okay, guys? Everybody? Yes, please. All of you? Respond, Ra. So that is what it is. So which
Yes, sir.
mu into m into g divided by L. If I do the integration of x, what will happen? X square
X square by 2.
and 0 to L divided by 1 plus mu. So now if I can substitute 0, it will go off. So it will become mu into m into g divided by L. So that I will bring the 2 also front. Is any problem for 2? 2 also, can I bring it front, everybody?
Yes, sir.
Yes. So what is remaining?
Yes,
X square. So x square means what? L divided by 1 plus u whole square minus 0 square. So that's all. So mu into mg divided by 2L. So this will turns into, what will happen? L square by 1 plus mu whole square. Is it okay, guys? Everybody?
Yes, sir.
So square and L will get cancelled. So what is that? Work done by the friction. Everybody. Work done by the friction, which is equals how much, guys? Anybody can tell? Work done by friction is equals to
Mu mg L by
L divided by 1 plus mu.
whole square into 2.
Yeah, here into 2. Okay, so that is what you have to do it. So here itself, can I write it here by 2? Is it okay, Rudresha? Mu mg L by whole
Yes,
square.
sir.
Okay, that's all. So this is the work done by the friction. So this is how you need to solve the chain problems. So always you have to remember the chain problems is very, very important. So with the same formula, mu mg, okay, divided mu mgl divided by 1 or 2 into 1 plus mu whole square. With this formula, so we can solve even in the case of like frictional force is existed also, we can solve. So in this case, no frictional force is existed. You can see that friction is 0. So that is why we will use, what is the formula base? If you want to calculate anything, we can use final kinetic energy plus final potential energy equals to initial kinetic energy into, initial kinetic energy plus initial potential energy. We can use it. If there is a friction, we have to use always the first formula. If there is no friction, you have to use the second formula. Now here, why we are choosing the again integration? Because every time all the part is not traveling the same distance. This part is traveling dx very less. Next part, if I take next part is taken next. So that whole chain, they are saying when the chain slips off completely, so means from 0 to L by 1 plus u, till there the entire chain is slipping. So that is why each part we have to find individually. So if you want to find individually, so mass of that particular part, if you want to find it, we'll go with the what? Integration. Am I right or wrong, guys? Integration, if you do it, we'll get the work done by the friction on this body when complete this chain is ready to slip off. That is what completely chain slips completely from the position. So the work done by the friction is equals to mu mgl divided by 2 into 1 plus mu square. Is it okay, everybody? Clear, Amma? Understand, Amma? All of you? So this is how, see that everything will be very, very tough. So this is how the questions will be there in the chain problems. So this is what about it. Still, if there is any concept and if I find it anything in NCERT, I will go through the NCERT in tomorrow also. If I find anything still missing, I will definitely let you know. Or else we can wake up morning and practice what we have studied. So this is what about very important concepts for NEET and as well as JE in the work, energy and power. Almost all the concepts I covered. So I not left anything. So now your choice. It is how much you practice for making the numericals faster. You people need to decide. Then tomorrow itself, without any delay, we'll go with the next chapter. So what is the next chapter I said? Everyone? Yes, please.
Rotational motion.
Rotational motion. So that is why before rotational motion, so let me teach that concept which I left in the fourth chapter. Okay, Rudreswar. So motion in a plane, I think. So motion in a plane, third chapter it is. Old book, it is a fourth chapter. So your new book, it is a third chapter. So let me teach that concept. That concept page number also I'll tell you. The concept which we left is yeah, we studied projectile motion and all, we studied it. Yes, the concept which we left is just a minute. This is laws of motion. I think yes. So laws of motion, circular motion, because we are going to study next rotational motion, correct? So before rotational motion, we need to study the circular motion, like a bank, a motion of a car on a bank road. That all that concepts, two concepts alone, I left it. If you take the law force and laws of motion, you see that chapter number 4, you will find it circular motion. I think 4.10 chapter heading is 4.10. You will find it. So that is a concept which I left it. So we'll discuss the two concepts in 1 or 2 days, and then we'll go with the next chapter. Is it okay, everybody? Clear? Yes. So you might be find that in the question also. So once that circular motion concept we study, and then we'll go with the rotational motion, so that it is easy even for us to understand. Okay. So this I'll stop. So kindly go through that whatever we studied. Morning wake up and 5 to 6 completely you have to practice for NEET. Otherwise, it's very tough because you are seeing the difficulty levels. So unless you solve plenty of sums, it is impossible to even imagine the exam. So that is what I'm saying. So keep on solving. Let it take even one sum 1 hour some days. No problem for us. So but you have to work out. So think smartly and work. Do you understand, brothers, everything? Rudreswar? So please carry on and work out. Morning wake up and do it so that we'll proceed. I think third chapter they started your school. Am I right? Correct?
Yes, sir.
Yeah. So no issue.
Exercise.
And nothing will happen. You finish it before itself, Rudresh, or exercise and all MCRT, everything. Don't leave any examples also. That is what is I want. Okay.
Okay, sir.
Yeah, discuss with your friends. Whatever you are, our team is there. You can go ahead and practice it. Girls also, please show interest and make it everything clear. Okay. Thank you, everybody. We'll meet tomorrow. Everybody revise the laws of motion concept if time permits. Morning you solve work and energy this week. I think whatever you fixed it, 1 week schedule you carry on and you start solving. Okay.